So is there another approach that we can use? I'm not going to deal with all the approaches that exist. I'm going to show you just two more different approaches. There are a myriad of methods that exist. I'm just showing you some alternates to kind of just pose the question for you. So this was the IAT, the individual anaerobic threshold proposed by Stegman in '81. And in review, McClellan writes this about the IAT. It's defined as the metabolic rate at which the elimination of blood lactate during exercise is both maximal and equal to the rate of diffusion of lactate into the blood. Now, think about that very carefully. Think about what McClellan is writing there. Actually, all they're writing is what we've been stating all along, which is what George Brooks postulated with his models of lactate exchange, and that is that what we measure in the blood simply represents the balance between the rate of production, that is elimination of blood lactate, and the rate of disappearance, that is the rate of diffusion of lactate. So let's start that again. So what he was postulating, and what they're saying, is that the elimination is basically the rate of disappearance, so the amount of lactate being consumed, and then they're saying that, well, okay, at this point it's equal to the rate of diffusion. That's the rate of appearance that Brooks is talking about of lactate into the blood. So there's nothing new in terms of what the IAT is meant to do. It's just what's new is the way in which it's kind of suggesting that we may be able to calculate this. So again, from McClellan. So what happens is we do an incremental test, but the difference here is, unlike what we've been referring to previously, we have to take the participant to the point of volitional exhaustion. You'll see why. They have to go to that point in VO2 max. But after the exercise test, the diffusion of lactate into the blood decreases with the fall in lactate production. So in other words, if you stop the test, then not surprisingly, we start to get a decrease in lactate production because we fundamentally have stopped exercising. So according to the original description of the IAT, the time during recovery when the blood lactate concentration equals the value measured at the end of the highest exercise intensity is assumed to represent a time when the elimination of lactate is maximal and equal to the rate of diffusion. A tangent drawn from this time during the recovery period to the exercise blood lactate curve is used to define the exercise intensity of the IAT. So let's see what they mean. Well, just to reiterate, this is from Brooks, so there's nothing new in their statement. Here's the blood lactate curve as one would anticipate, and in this example, we've taken somebody, or Brooks has taken somebody to max. Here's our rate of appearance, here's our rate of disappearance. Where the rate of appearance starts to accelerate, this is our kind of lactate turn point response, and the rate of disappearance starts to slow down because fundamentally you've got less and less inactive muscle fibers. The rate of appearance carries on accelerating because you are using more and more fast twitch fibers, exactly as the IAT model suggests. And this is what we show. So what you have is, and this is again from the McClellan paper, here's the incremental test. Now notice what they've done is they've changed the x-axis to time, and that's really just to make this easier to understand. But what happens here is these each represent an increase in exercise intensity. So these are probably happening in the region of every 3 minutes. This is 0. So actually maybe this is closer to 4 minutes. Yeah, maybe they're every 4 minutes actually, aren't they? 4, 8, 12, 16, and so on, 20 minutes. So these are every 4-minute increases. And they're increasing the workload by whatever the progressive increase would be. And we get that conventional response that one would anticipate seeing. Now, if you look at that curve, ignore the kind of the lines that have been drawn at the moment. If you look at that curve, it's actually quite difficult to see visually where the transition would be. If I do the 4 millimole response, it goes into the middle of nowhere. And it's certainly probably higher than where you may anticipate it would be. I mean, most people would probably take a guess that this is the lactate turn point down here, because it does seem to be where this acceleration occurs. But the novelty with this is that notion of the rate of appearance and disappearance. And what Stegman proposed, and really what McClellan took on further, was, well, we're going to use exercise as our proxy indicator of appearance of lactate because you're fundamentally producing it. And we're going to use recovery as our proxy indicator of the clearance of lactate because you're no longer a producer, but you're turning into a consumer of lactate. And so what happens is at the end of the test, the participant remains still, and lactate is then drawn continually at minutes 1, 3, 5, 8 and 10 post-exercise. And so as was reported, one would expect that the lactate concentration starts to fall because the rate of appearance starts to slow down because we're no longer producing as much lactate. So the argument the authors make is, which one can contend is actually a very, very strong argument to a certain degree, which is, okay, the transition, LT2, represents that point, the perfect point of balance where the rate of appearance exceeds the rate of disappearance of lactate. Anything beyond that, then appearance exceeds disappearance. So assuming that this curve here represents appearance, okay, now you've got to contend, you've got to understand they're not ignoring the idea of appearance and disappearance during exercise, but fundamentally, beyond this point, appearance must be exceeding disappearance. And the curve in recovery represents fundamentally disappearance of lactate. So what they recommend is you draw a tangent between the highest lactate concentration, so this is why they have to go to exhaustion, and the lactate curve in recovery. So you're kind of marrying these two up. And then by drawing an intercept from that point back to the lactate curve, it is connecting, theoretically, appearance and disappearance of lactate, and this point here will therefore represent what they call IAT, which is fundamentally what we're defining here as the lactate turn point, or LT2. So it's a really clever way of trying to connect our understanding of the lactate response to exercise and also overcoming issues of visual inspection and also overcoming issues of using fixed lactate concentrations. But there are clearly a lot of issues. First issue is this. You need somebody to go to volitional exhaustion. If they don't go to volitional exhaustion, then the net result is you never get the overshoot in the blood lactate concentration that we see in recovery. So it does mean that that exercise test has to be to max, and we've already learnt in previous classes about how difficult it is to get somebody to go to VO2 max. The second thing is, if you do not get these samples rapidly enough in recovery, you will miss the overshoot. So you have to get these lactate samples really, really rapidly and really precisely in recovery to get this curve. Any delay means that you fundamentally miss this lactate concentration because the balance between production and consumption is starting to alter, and it's altering very, very quickly. The third thing is this, that there is no justification for why it is minutes 1, 3, 5, 8 and 10. So we don't know that. Nobody's ever really examined why that is the case. Why is it 1, 3, 5 and 10? Why is it not 30 seconds, 1 minute, 2 minutes, 6 minutes, 8 minutes, 12 minutes, for example? Because that will change that curve. That will change the response pattern. Where the timings will change the response, will therefore change the intercept. But the big one that has never really been accounted for, McClellan was really the first author to try and reflect upon this. But what do you do in recovery? Now, the traditional approach from Stegman was that recovery should be fundamentally inactive. The participant just stands there. But what happens if you do an active recovery? Because if you do an active recovery, you would speed up the removal of lactate. And so anything they do changes that lactate clearance. Now, therein lies the issue. If I've got the participant doing an inactive recovery, they're standing there, it's not very pleasant for the participant. But one could argue it's probably controlled. Should it be a stood recovery? Should it be a sat recovery? But if they do an active recovery, because that's what the athlete would want, how active is active? What intensity can they do that recovery at? That will change the blood lactate concentration or the blood lactate concentration response, which will therefore change the intercept back onto the exercise lactate curve. So there's an awful lot there to kind of think about methodologically. So unfortunately, although the idea is quite neat, it really doesn't bring us any further forward in terms of understanding and having a method that is suitable for identifying the LT2 response.